Hello, physics. So this is a little different. Usually I'm drawing something or diagramming something or calculating stuff. Not so much today. Just want to go through and remind you or tell you, depending on which group you're in, group 1 or group 2, about like formatting for how you're going to write up labs and what to include and what to talk about type thing. Because I would wager that you haven't actually like typed up or written up many labs before in the past, and just want to give you like a formatting lesson basically. So I'm doing this in Microsoft Word. I'm sure that you can do all of these things in Google Docs. I just happen to know Microsoft Word a little better. That's all. If you're having trouble finding something in Google Docs, send me an email. I'll test things out and see what happens. Okay. So the first thing, usually, I'm sure that you would like make your header like blah 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 words, right? I don't need any of that. Please don't do any of that. You're just wasting space, you're wasting time, you're trying to make something into 2 pages, it's only 1 page, don't bother. Alright? Go up here to the header, and I want it, let's see. I say that I'm more familiar with this. Well, yeah, I guess it doesn't matter. Top left or top right. Top somewhere, right? I kind of prefer top right, so I'm going to align it to the right. I just want your last name and the page number. Top of page, plain number at the top. Okay. Cool. Okay. So, like that, right? Now, what you'll find, close header footer, right? So there it is there. And if I just like, I'm going to hit enter until I make a new page. Look, it automatically updated the page number. I've had people in the past saying like, oh, I typed in the number and then I had to type in a new number for the next page and it changed it for the, no, change it, it will change it for the first one. Because if you just type it in, it's going to say that at the top of every single page, right? Now, Microsoft Word has a literal option that is just page number. I am sure that Google Docs has a similar function. It's probably somewhere in the insert menu. Again, I'll do research. If you can't find it, just let me know. I'll do my homework too. All right, the next thing that you'll want, and this is me remembering things exactly how they should be. I'm gonna bold it and underline it. Title, the title of the lab. So this lab might be acceleration of a soccer ball. That's a valid lab title. You can also just label it Lab 1. It's also a title. But I want a title, right? I want centered. Then go back off to the side. And your next piece will be, why are we doing this lab? What is the purpose of this lab? Now here's what I don't want. You don't need to tell me the purpose of the lab is to do a thing. That's what the title of this section just did. Told me that this is the purpose. So, for this lab, determine the acceleration of a soccer ball on different... Oop, missed it by that much. Surfaces. Right, there it is. Your purpose is like your hypothesis. I know you've used hypothesis before as like, will the different surfaces have an effect on the acceleration of the ball? So instead of posing it as a question, we're making a statement. Why are we doing this lab? We're doing a lab to determine this thing, to calculate this thing, to observe this thing, right? There it is. There's my purpose. Okay, next. After your purpose, tell me what you used. And when you do this, the easiest way, the nicest... Nope. Okay. Nicest way to do it is just a bullet point list. So we had a soccer ball, we had a meter stick or tape measure, right? We had stopwatch or a timer. Students actually like ask fairly commonly, like, do we need to include students? You can assume that people are going to be involved in the lab, right? But the other stuff. So here's the other stuff. If there's something else you can think of that we used, include it. If not, don't include it. All right, your next section is something called the apparatus. Now the apparatus is something where you're just going to leave yourself some space, because what you're going to do is draw a setup. You told me what we need. Now show me how are we going to use it. So this is a visual representation. This is a drawing. If you are not a good artist, stick figures are great. If you are a good artist, feel free to impress me. I kind of like seeing, fancy drawings and stuff here. You don't need to be fancy. This is just an opportunity to do so if you want to. The next section is a procedure. Now that I have the list of materials, now that I know how we should kind of arrange ourselves, what should we do? So procedure. Step 1. Measure out distance markers for students to time. Right. Step 2. Line up students at the markers prepared to time the ball. Step 3. Count down a time to kick the ball. Step 4. Have a student kick the ball down the line of timers with each timer, and then etc., etc. So your procedure is literally like step by step. What did we do? What did we keep track of? What did we measure? What, you don't have to say why here. It's just literally, this is what you need. This is how you should set it up. This is the procedure you should follow in order to kind of get the results that we got. Right? The next section is data. Now for this, it might be something like see attached table, or see attached graphs, or maybe you were going to make a table. So let's say that you had, I don't know, this many, just say that you only had 4 times, right? So for group 1, I might label this grass, and this was 3 meters, 6 meters, 9 meters, 12 meters. You have your 4 times, right? And then the dirt, and you have your 4 times, and then turf, and you have the 4 times. Maybe you need more, maybe you need less, right? You can... Oh, undo. If you need more space, you can do that. If you need less space, you can do that. Yeah, sure, do that. So if you need a table, you can type in the table. If you made graphs in Logger Pro and you'd like to attach them to the lab, you can attach them to the lab, right? And you can say see attached graphs and include them at the end. If we were handing things in physically, you'd staple them at the end. All right. The next section is the analysis, right? And this is going to be the majority. This and the conclusion, which are the only 2 things left, right? We've done 1, 2, 3, 4, 5, 6, 7. There's 7 points to this, right? So in the analysis for your lab, this is where you're going to include what did you do with your data, right? So using the collected data, we calculated velocities in between each distance marker. To do so, we used the equation, and this is where it'll get a little tricky, right? I want you to actually insert, and there is, okay, my face is covering it up, so give me 1 second. Up here, in Microsoft Word, there's an insert equation, and when I do that, let's see, V equals, and then I can put in, oh, my face is blocking stuff again. I can make a fraction. So I can do something like this, and I can make it time in the bottom and distance in the top. And look, there's my equation. And look at how it looks nice and pretty, right? Again, you can do something very similar in Google Docs. It's the same idea. It's in the insert equation, and you can make it look nice. That way I don't have to deal with something that looks like this. V equals d over t. Like there's a big difference between these two things. This is nice and clean. This is a little sloppy. Make things look nice, kids. Okay. We use the equation v equals d over t, where v is velocity, d is distance, and t is time. We then calculated accelerations, blah blah blah, right? Okay, so our goal, right, is to find acceleration, so you need velocity before you can do acceleration, so you'll explain that. Explain that, you know, you took an average of the accelerations because it's what I asked you to do. So that from the accelerations, we determined the average was this, right? During our calculations, maybe you found something odd. We found that the average acceleration was positive, even though the ball slowed down over time. Right? That would be odd. The ball's going forward, and it should be slowing down, because there's stuff like slowing it down, right? There's friction. We haven't talked about friction yet, but we will. So, you have a discrepancy between like what you calculate and what you know should happen. This could be due to human error. You will not use these words. This is a bad phrase. Don't use it. This could be due to the ball not traveling in a perfectly straight line. Or it could be due to the timer's beginning or ending the time inappropriately, right? At too early or too late, right? So the other thing that you want to mention in your analysis, this is where to mention any potential sources of error. Be specific. Be specific. Be as specific as you can, okay? Now, you can do your analysis. It should be a paragraph form. I don't want like bullet points. I don't want numbered lists here. Give me paragraph form. You also don't need to list every single number and every single calculation you've done. Give me the broad version if you want to give one or two examples saying, for example, in between 3 meters and 0 meters, these are the numbers that I plugged in so that I have an idea of what I can do to simulate this process, and do that. But you don't need to spit out every single thing that you've done, okay? Finally, the last thing, the last section is, just kidding, caps lock is still on, the conclusion. Now, in the conclusion, mention, did we achieve our purpose? Did we actually get there? Right? Most of the time we will have achieved our purpose. Were you able to determine the acceleration of the soccer ball on the different surfaces? Yes. Right? So our purpose was achieved as we were able to determine the average acceleration of the ball on these three surfaces. When we looked at them, you know, and this is a place to also compare your expectation to your analysis. We expected the grass to have the largest acceleration and the turf to have the lowest acceleration. According to our data and calculations, this was true. Or according to our data and calculations, this was false. The other thing to mention here is how to improve upon your errors. What could we do better? How could you force the ball to travel in a straight line? Well, you can make it on a track, right? You could set up some boundaries so it can only exist within a certain space. You know, perhaps you could use a ramp, right, and let the ball roll down the ramp instead of having someone kick it, because then it would be the exact same speed to start the whole every time. You could use sensors, right? There are any number of things that you could do to improve this for the future, for future reference. If somebody else were reading this and looking at your analysis and saying, I wonder if that happens every time. I have all these things. I wonder if they had any improvements. This is where to include that stuff, okay? Now, your lab might be a couple of pages. If you start getting into like 3 and 4 pages, it's very likely that you've written too much. if you want to send me like, hey, does this look okay? Should I have included this here? Did I include too much? Did I include too little? You can send me a draft, a practice copy for the first 2 labs. I think I'm going to call it 2 labs. And then after that, it'll be at your discretion. You're going to have to figure it out. All right. Now, those are the sections: purpose, material, apparatus, procedure, your data, the analysis, and your conclusion. Your header is just up here. Make sure you have a title. I will put up a bullet point list of these also on the downloads on the main bulletin board. All right? Okay. This was something that I wanted to cover because I would like your lab by next C day. All right, so kind of like the end of next week. In any case, I will see you again on your B day. Try to, start typing something up, get a feel for this. It'll be a little strange at first, but once you figure out how to do it, it'll go pretty smoothly. All right? Take care, kids.